Some molecules cannot be correctly drawn with only one Lewis structure. Instead, they are a blend of two or more structures. You can always tell that you have a resonance structure because there will be a double-headed arrow. So for example, down here, this is ozone, O3. There's a double-headed arrow. So ozone can be drawn with a double bond here on the left-hand side, but it also could be drawn with a arrow here on the right-hand side. Well, which one is it? Is the double bond on the left or on the right? And the answer is it's a blend. So the electrons in that bond, they move. You often see resonance structures have a double bond and you're really just moving the double bond around. You can take and do a blended structure with a dotted line right here instead of the double bond, showing that the double bond could be on the left or could be on the right. The real structure is a blend of both the left hand and that right hand. And so this is one way that you can draw that bond. So really, instead of a single bond and a double bond, it's really a bond that's 1.5. Here's another molecule that has resonance, and this is benzene. So benzene is a ring and it has double bonds that are alternate. When scientists went to see exactly where, if it was a single or a double bond, they found that it was a blend. Again, like a 1.5. So we often put them together instead of drawing them separately with resonance structures. There's that double-headed arrow. You'll see them just draw a circle showing that those electrons there are shared amongst all the carbons. This is the polyatomic ion nitrate, and you can draw it like this. Notice that there are brackets because this is an ion. It does have a negative charge, and I can put a double bond on the right-hand side or the left-hand side or the bottom. And all of these are resonance structures. There's that double-headed arrow. When you look at the molecule in reality, there is resonance. Those electrons are moving around that nitrogen. The reality is it's more like a 1.3 bond, so 1 1/3 bond between each oxygen and the nitrogen. But you would draw all the resonance structures with these three resonance structures connected with a double-headed arrow. So let's practice drawing a resonance structure. So this is acetate ion. So it is a negative ion, and there are some unbonded electron pairs around the oxygen. Oxygen always has unbonded electron pairs. Okay, so there's my acetate, and I'm going to draw one more. So I can draw another resonance structure. So I'm going to put it in the little brackets saying that we've added one extra electron. And how I'm going to draw this is I'm just going to move that double bond. So the two oxygens, they're going to attract the electrons equally. And so that's why we have resonance. So I can draw it as a double bond on the lower right-hand side. And then, of course, the first one, the double bond on the upper right-hand side. Let me just put this little methyl group here. These are both the resonance structures. You could draw a dotted line to show that those electrons are shared between both the oxygens. They're equally attracted to it. So in your packet, you can draw an SO3 molecule and draw it some different ways. Try to make sure that they all have 8 valence electrons, and you will see that there might be some double bonds that you could draw and move around.